Assalamualaikum and greetings to everyone. Welcome to my final year project presentation. I am Mohamad Faizal Hamidun, a final year student in Bachelor of Mechanical Engineering. The title of my FYP is Mechanical Analysis and Development of Portable Aspirator. I am being supervised by Professor Madia, TS Dr. Engineer Sharul Azam Abdullah. For the project summary, in this project we used to analyze and develop the design of portable aspirator that is smaller, no changes in efficiency, and easy to use. For the introduction, medical suctioning device is a common device used in the field of medicine. This device used to create suction in order to clear a waste of blood, saliva, vomit, or other secretion. This device also used to save life of people and prevent pulmonary aspiration, which can cause lung infection. During surgery, this device always used to clear path that doctor want to operate by suctioning all of the blood spill after cutting apart. There are three types of suctioning device, which is manual suctioning device, stationary suction device, and portable suction device. Next, literature review. The first medical suction device was produced by a cardiologist named Pierre Edward Potin in 1869. It is a manual device used a pump to drain the abscesses and fluid build up in the chest in order to prevent heart failure. During the late 1970s, suction devices were extremely large and fixed to the wall. Manual suction device is a device that do not use electricity and can be operated by hand. It used to expel mucus from a child nasal cavity. Stationary suction device is a device that fits to the hospital's wall. Portable suction device is designed to be lightweight and can be used during transportation of the patient. For the problem statement, firstly, the product that available on the market is too bulky, and second, it is too expensive. The price range from 300 and above. Lastly, high energy usage, and it consumes a lot of electricity in order to operate this device. For the objective of this project, first to design the portable medical suction device that is smaller in size and easy to be carried around. Second, to analyze the needs of the new design and evaluate whether the design can be used as medical device. Scope and limitation. The scope of this project involving researching, innovate, modeling, and analyzing the portable aspirator that available on the market. The limitation of the project is that this device is only used for human only. It cannot be used on animal and insect. Modeling and analysis process only be done by using CATIA and SolidWorks only. Lastly, further research show that no standard model for portable aspirator using 12-volt power supply. In methodology section, we have two types of chart, which is flow chart and second is the morphological chart. In this slide, they have been shown here is the flow chart of the whole process of the project. So the first one, we start with making a literature review of the project, and second, by making design in CATIA, and third, by the simulation of the design. If it is yes, it will move to the analysis of the design. If it is no, it will back to the making design in CATIA. The same concept applies to the analysis of the design. If it is yes, it will move to the conclusion and evaluation. If it is no, it will back to the making design in CATIA. In this slide, we show the flow chart of the design process. First, we will move to the determination of specification of the product, and second, selection of design parameter. Next, we'll move to the conceptual design generation. Next, to the concept evaluation. If the concept evaluation is no, we will redesign and we'll move back to the conceptual design generation. And if it's yes, we will move to the preliminary design. Next, we'll move to the detailed design, and lastly, to the design analysis. Next, we'll move to the morphological chart. This chart is used to make a comparison and produce a sketch based on the design that available on the market. As we can see here on this chart, we have three types of options. Such as the body, we have three types of body that appear to have different size and dimension. As for the motor, all of the motor have the same specification that will suffice the portable suction device. However, the difference appear to be on size and dimension of the motor. As for the battery, the difference you can see here is from the battery life and also the size of each battery. And lastly, for the liquid collector, we have three types of liquid collector that have different unlocking mechanism. Based on the morphological chart, we have produced two types of sketch. The sketch 1, we have on and off button, handle with battery, and also liquid holder. While sketch 2 also provide the same specification as sketch 1. However, The difference between both sketch is that the location and how we put the battery on the design. So in order to evaluate which sketch is the best, we're going to be using push chart. So next we will move to the preliminary result. In this preliminary result, we have three sections. The first section is the push chart, the second is the detail design, and the third is the analysis of the design. So next we'll move to the push chart. In this push chart, we will evaluate and determine which is the best design that we'll be using on our project. So the criteria that will be evaluated is cost, safety, comfort, stability, and weight. Okay, for the sketch 2, we have more dimension than sketch 1. Thus, sketch 2 will be more expensive than sketch 1. That's why the cost will be negative for sketch 2 and sketch 1 will be positive. In terms of safety, sketch 2 is more safety than sketch 1. In terms of comfort, both designs are comfort to be used. In terms of stability, sketch 2 is more stable than sketch 1. In terms of weight, sketch 2 is more heavy than sketch 1 due to more dimension, thus it will go negative on sketch 2. So the net total for sketch 1 is 6, while the net total for sketch 2 is 12. Thus we will be using sketch 2 in this project. So next we have a detail design. In this detail design, the part that we'll be using is the body part. So this is the isometric view of the body part, side view of the body part, and also front view of the body part. Next, we'll move to the analysis. For the analysis of the body part of the design, we will be using two types of analysis. The first analysis that will be used is von Mises stress analysis, while the second analysis that will be used is strain deformation analysis. Both of the analyses will be put under 176 Newton of distributed force equivalent to 18 kg force. For the von Mises stress, it will be used to determine which point will fracture first. As we can see on the von Mises stress diagram, there appear only small warning red color exists on the diagram, while all of the body part is still on the acceptable range with the color of blue and green. And for the strain deformation analysis, we also can see a small red dot appear on the diagram, while the other of the body part of the diagram is still on the acceptable range, which is blue and green. And for the conclusion, we can conclude that both of the analysis show that the body part of the design is still in acceptable range and the small red dot can be neglected. This shows that this design can withstand on 18 kg force. So that's all from me, and thank you for listening to this presentation. Assalamualaikum.